Hello everyone, welcome back to our channel. I am Anisha, your maths faculty for class 12. We have started chapter 5 of class 12, that is continuity and differentiability, and we have started with solving the questions of exercise 5.1. Let's move ahead in the list of this question. Now in this video we will solve question number 14, 15 and 16 of exercise 5.1. Let's move ahead. So let's our first question. So our first question is question number 14 of exercise 5.1. So in this question, what we have to do? Discuss the continuity of the function f where f is defined by. Okay, this is our f. Now we have to discuss the continuity of the function f. Okay, so whenever we know that we have how we check to the continuity of a function, we find its function value. First of all, function should be defined at that point, and we find its function value. Then we will find its limiting value at that point. Then if the function value and limiting value are same, then we say that the function is continuous at that point. So now what we have to do here, we have to check the continuity of the function. So we know that the continuity of the function means to check whether the function is continuous or not. Okay, as in this, what we have to do to check the function is continuous or not, we know the function definition of a continuous function. The continuous function is the function f such that it is continuous for any point in the domain. Any point in domain. I just writing the domain. I will say my domain by D. I'm just writing the definition, so I don't have to write it explain you guys again and again. So let's begin with question number 14. So I have already told you in many times in the previous questions also. Let me repeat that also for this video, that whenever you have a function f which is splitting at some points, then what we have to do, we have to just make the cases. Case one, first case when it is before, case one that contain the points before that, case 2 that contain exactly that point, and case 3 that contains the point after that. Okay, so for here for this video I will explain the question number 14 completely theoretically. Then we will move the different ways how can we directly check the questions about its continuity without solving theoretically, because I know that you guys will be much more comfortable now doing the theoretical parts of the continuity because it's quite easy now for you. So let's begin. So here, as you can see, our domain. First of all, always list your domain. Here, as you can see, your domain is close 0 to 10. So let's divide the function. So for what? So as it is starting from 0, so we will take I will begin with the cases. I will list you the cases and we will do case by case. So first case when my x is 0. Second case, okay, case 2 when my x is in between 0 and 1. Okay, so in this, I think in this page I will cover only 2 cases. So let's move ahead. So for case 0, case 1, that is x equals to 0. As you can see, as your domain is this, you have 0 to 10 only. So you can first of all find the function value. So our f of 0, it is defined as 3. Now the limiting value, as you have taken the domain only this part, so you have to take only the right hand limit, because the function is not we don't have the function value when you come from the left. So only limit we are left with the right hand limit. So we only have to check the right hand limit to check the continuity. So as you can see, our right hand limit x tends to 0 positive of f of x. This will be also 0 3. So from here you can say that the f is continuous at x equals to 0. Now let's move to the case 2. I think this is just a piece of a cake for you. So that when your x belongs to open interval 0 1, as you can see, it's just a constant function, and we know that the constant functions are always continuous. So let me give you the theoretical proof also. So take any point a, x equals to a, that belongs to our 0 1. So for any this arbitrary point in 0 1, we will prove that this is continuous. So first of all, we find its function value. We know that this function value is 3. We find its limiting value. So limit of x tends to a, we know that f of x, as the function is defined as a constant 3 for all points. So this limit value is also 3. As you can see, both are same. So from here also we get f is continuous at x equals to a. So this is for all points that belongs to open interval 0 1. Now I think we can cover another case also. So case, okay, first of all, what we do is we will find the intervals, then we will look for the particular points. So we will take the case 3 as when my x is belongs to open 1 to 3. So open 1 to 3, as you can see, the same case we have did for the case 2, that as it is a constant function, just the value is changed. It is like instead of 3, it is 4. So like I think you guys can do this as in your homework, because it's just same to do this all. So from here also what you get, f is continuous for any point in 1 comma 3. Now let's move to like case. I will write the case 4. Let me write in the next page. So what is our case 4? So case 4, take the interval when x belongs to open interval 3 to 10. So as you can see from here also you have to do the same thing, because you have the constant function phi here. So in this also you can easily, same as case 2. So this is also homework for you. This is also homework for you to like prove that the function is continuous for any point in x belongs to 3 comma 10. So in open interval 3 and 3 10. So here also from me that f is continuous for any point in the, okay, as you have like this is same as the case 2. Here also you will get the function is continuous for any point in open 3 comma 10. Now as you can see we are only left with to check. We have done with 0, we have done with the like we have done with close 0 1, sorry, close 0 open 1, done with O 1 to 3, 1 to 3, then 3 to 10. We are only left with the points 1, 3 and 10. Let's move to check this as a like our other cases. So let's take it as case Case 5. Case 5 when my x is exactly 1. As you can see, your left hand limit, your function here is defined as 3. Your left hand limit and your right hand limit, I think it's very easy to find that your left hand limit for x equals to 1 is 3 and your right hand limit is 4. So this is 3, this is 4. From here, what you get, limit not exists. Limit not exists, so there is no point to check their equivalence with the function value. So by this what you get, not continuous at x equals to 1. Similarly we will do with the case 6. This will be same as the case 5. This will be homework for you. So case 6 will be when your x is exactly 3. So from here also you can like it will be homework for you, because it is same as you are doing in case 5. It's same for you. So from here if I tell you virtually, then it is like when for left hand limit is 4 and for its right hand limit is 5, so limit does not exist, and the same thing is happening here. Now so from here also we have not continuous at x equals to 3. Now we are left with the last point, that is our case 7 where my x is 10. As you can see, from here also you can see that the function value is 5, and here also when you have only this part, so you can only like reach to the point from the left hand side. So only limit you have to check is your left hand limit. As you can see, your left hand limit here, your left hand limit is also 5 and your function value is also 5. So from here also what you get, the function is continuous at x equals to 10. This is same as you did for the case 1. Here what is the difference? You have to check with only right hand limit here, and in the for x equals to 10 you have to like check only for x for left hand limit. So this will also homework for you. I know I am giving you a lot of homeworks, but I have did the same parts, like same cases for you. Now it's your job to do the similar ones. So it is from here what we get, continuous at x equals to 10. So now let's make the conclusion. So what is our conclusion? So our conclusion is, may I change the pen? Okay, I should change my pen for the conclusion. So I will take it a red pen. So as you can see, the function is continuous for all, like for any points in close 0 to 10, x equals to, I think, 1, x equals to 3, except these 2 points. As you can see, the function is not continuous at some points on the domain. So from here also you can conclude that f is not continuous function. Okay, this is not continuous function is our conclusion, and another conclusion is x. It is continuous at all point in close 0 to 10 except the point x equals to 1 and 3. So we are done with the our part what we have to do in the question. But if I try to explain you this question, like this all is theoretical part. Yeah, I know you can easily do it by yourself. But if I try to explain you, just try to explain you this question in a simple way. So what we can do is, as you can see, this is a simple graph. You can simple function. You can easily make its graph. If I try to make its graph, so because we know that we have a graphical approach also, like I have explained in the introduction video also, that you must guys see that because it's very helpful for you whenever you have to just recap your chapter. So, but let me explain the graphical approach also. In graphical approach, what we see, we will make the function of graph of the function. Wherever you have to lift your pen, then the function is discontinuous at that point. So let's make the graph. So our graph is starting from 0 and it is go till 10, and it is divided in, let's say this is 1 and this is 3. I know this is unequal, but this is just I'm trying to explain you. So we know that from 0 to 1 the function is defined as 3. Take it as 3, this is 4, and this is 5. This is our y, this is our x. So from 0 to 1 the function is defined as like this. Sorry, this is also included. Now from 1 to 3 it is defined as this. This is not included. And from 3 to 10 it is defined like this. This part is included. To this part is included. So as you can see, you have to jump your function only at 1. Like you have jump here and only at 3. So the function is continuous at every point except 1 and 3. So this is the graphical approach. So now let's move to the another question. Next question, that is question number 15. Here also we have to do the same thing. We have to discuss the continuity of the function. We have to do the same thing. We have to discuss the continuity of the function. This is our function. Now what I will do is I will just give you idea, and this will be homework for you to check check the points of discontinuity. I will tell you the points of discontinuity also, but what is a homework for you is like to do the theoretical part, because I know now the theoretical part is like piece of a cake for you. Now let's move ahead. So as you can see, the function is defined over whole R. Here, always write your domain. Our domain is complete R. Now, for less than 0, it is defined some another function. From 0 to 1, it is defined as 0. And from x greater than 1, it is splitting to another function, that is 4x. So what I always tell you, whenever you have a splits, do your splittings, check the points beyond that. So I will just make the graph. I will not tell you, not bore you also. What I will do is just explain you by graph now, and your homework is to do its theoretical part. So what we have, that take it as, I know this will be unequal for you. Okay, so what I will do is I just make it properly equally graph. So this is 0, 1. Let's say this is 1. So this is 1, 2, 3, 4, and this is -1, -2. Okay, and now I am not making this part because we don't okay, we also need that also. This will be -1, this will be -2. Okay, so on, and this will be 1, 2, 3, and so on. So this is our x-axis. This is our y-axis. Now let's start making our graph. So as you can see, for x less than 0, the function is defined as 2x, and it's very easy to plot the 2x graph. So for -1, the function value will be -2. For -1, the function value will be -2. And if 0 is included, so then here the function value is 0, but the 0 is not included here, so it will be open case. First, I am just making the graph for x less than 0. So our graph will be like this. It's here. This dot is here, right? So our graph is this. It will be a straight line, right? as it is a f of x equals to 2x. So this will be a straight line. Now, so forward for 0 to 1, the function for close 0 to close 1, the function is defined as 0. So this is 0. So as you can see, this is 0. And at C1 also, this is the function value 0. Now, and beyond 1, it is defined as 4x. So it will be, your graph will be 4. This will be open from this because 1 take the value of 0. And this will be like this. Okay. So now as you can see, your function is making a jump. Like if you see a graph, this is like starting from here, this you have to make a jump at only at x equals to 1. So what is the only point of discontinuity is only point of discontinuity is x equals to 0. Sorry, x equals to 1. The only point of discontinuity is x equals to 1. That means only at x equals to the 1, the function is discontinuous, otherwise the function is continuous. Now, so from here, what we can make a conclusion that the function is not continuous function. Not continuous function because for continuous function should be continuous at each and every point of the domain. And as you can see, one is in the domain, but the function is discontinuous at that point. Now, the theoretical part is homework for you because I know you are master in this now. But so this type of question, what I'm trying to say, why I'm not doing the theoretical part, because it's very easy if you know that, like if you know what you have to do. Like as from the graph, you can imagine that the function is discontinuous at one, and at the each other points at the function is continuous. So like first of all, whenever you have this type of question, always make its graph. If the graph is easy, first of all, always make it graph, then do the theoretical part, because by graph you can make the conclusion easier. And this type of question is very good question for the board, because like this type of question of continuity always asked in board for, I think, like about 2 to 3 marks easily. And it's like a basic question, every student should understand this question. And this is like you can easily see in the board paper also. If you are doing your giving a pre-board, you can easily see this type of questions also. And like for any practice set, if you are trying, you can see these questions in that also, because like this type of questions are the base of the continuity. Like continuity demands this questions, so you guys should do this type of questions. Let's move ahead for question. I'm just giving you practice, just giving you idea. Your job is to complete the whole part. So now let's move to question number 16. Now, as you can see, the question number 16, we have to do the same thing. We have to check the continuity of the function. We are given with a function for, like, it is defined as for less than equals to minus 1, it is defined as a constant function -2. For x greater than 1, it is defined as a constant function 2. And in between -1 and 1, it is defined as 2x. So what will we do? It's your homework for you. Like now I am not gonna make its graph also, because it's homework for you, like to apply what we did in question number 14 and question number 15, to apply this in question number 16. That in question number 14, I have explained you the like theoretical part, all also the graph also. And in question number 15, I have explained you the graph part also. Now in question number 14, it's your homework, because as you see, because the whenever you see in your exercise a same type of question, you can think like this is a important kind of question, because whenever you have a question of the same kind now, then it's a point where, like, specifying that these questions are important questions. So your homework is first make graph, so you can guess what you have to do. And the second will be your second homework, do its theory part. Nothing hard. I have just did the whole thing for you in the question number 14 and 15. So if I try to give the answer, not try, I will give you the answer. I will give you the answer also. So your conclusion will be the function is continuous for each and every part in the, like, for, as you can see, for this is -2 and this is 2 also. Okay, so conclusion is this f is a continuous function. Now use a definition of the continuous also. Oh, okay. For that, if I try to make your work simple, your domain here is whole R. So what is your homework? to make its graph, make its do its theory part, and I have give you the conclusion that the function is continuous function. Use the definition of a continuous function to like check whether you are doing right in this two parts. Okay. That's all for this video. We have completed the question number 14, 15, and 16. Do this homework. As you know, this homework will be very helpful for you. Do all the questions once by yourself. If you have any doubts, if you have any doubts which I gave you in homework also, you can just ask me in the comment section. Till next video, please like, share, and subscribe this video to like you can easily get the next videos of this chapter. So let's meet in the next chapter now. Thank you.